This is a video about graphs, and we're going to be looking at how to interpret them and also how to draw them. Now, graphs are a way of representing data. So essentially, we can show a relationship between two different values. Now, an example I often use is, say, for example, my age, I'm Mark, is my sister's age plus 2 years. So essentially, I'm 2 years older than my sister, and so when I'm 30, she's 28, and when I'm 50, she's 48, and when she was 10, I was 12. So I'm always 2 years older than her. Now that is a relationship. Now it's a fairly obvious relationship, but sometimes relationships are a little bit more complicated than that, okay, in terms of numbers. And so one of the best ways to sort of visualize them or to understand them is to draw them on a graph. Now, the most common graph that we will see is the graph y equals x. Now, what that means is that for every x value that you have on a graph, the y value will be the same. So we could actually represent that with coordinates. So when x is 1, y would be 1. And when x is, say, 30, y will be 30 as well. So these are just different coordinates on a graph. Now, how we draw that is just a straight line that goes through here. And as you can see, that when x is, say, 10, y will also be 10, hasn't been brilliantly drawn there. And when x is, say, 20, y will also be 20. And also when x is, say, minus 10, y will also be minus 10 there. If I want to represent a relationship like, let's do one here, I'll do my y-axis and my x-axis here. Now the y-axis is always vertical and the x-axis is always horizontal. And if I want to show this relationship here, okay, where this crosses at 3, what will be happening here, and if this one crosses at minus 3, what we can see here is that the graph has gone along by 3 and up by 3, okay, and it's crossing the y-axis at 3. Now this graph would be y equals x plus 3. Now we can see that the gradient of this line, okay, the steepness of it would be the same as the steepness of the y equals x. It's just the whole graph has been moved up by 3. Now I'm going to show you how you can actually draw these and how you can interpret these graphs. So all graphs follow, okay, that can be written in this form: y equals something x plus something. Okay, now I've just shown you one where y equals x. Well, in fact, what that actually is y equals something x plus something. It's y equals 1x plus 0. So we don't have to write the 0, we don't write the 1, so that gives us the y equals x. But as I said, all graphs can be written in this form. Now, the value in front of the x here, okay, we call that the coefficient of x, which is just a fancy way of saying the number in front of x. That is our gradient, okay, or steepness. Okay, so whenever you see a graph, if there is anything written in front of the x, it is the steepness of that graph. So in this case here, because there's a 1 in front of the x, that's 1x, it means our steepness is 1. That means for every 1 across, it will go up by 1, okay, by 1 and 1. Now I'll go into a little bit more into the steepness in just a second, or this gradient. Now the number that is on its own is the Y-intercept, okay? This is the Y crossing point. Now, the y-axis actually occurs, this is the y-axis here, the y-axis, this axis here, actually happens when x is equal to 0, because when x is 1, 2, 3, so 1, 2, 3, etc. This might be minus 1 here. What's happening here is that that's when x is 0. So if you substitute x is 0 into this equation, all that will be left is this. Now again, you don't need to worry too much about that, but I just need you to understand that, or at least remember this rule here. Okay, so when you write y equals something x plus something, the coefficient of the x is the gradient, and the number that's on its own is the y-intercept. Now, very often we see that written as y equals mx plus c, okay, where m is the gradient, okay, and c is the y-intercept. Now, m being the gradient. I spent a long time trying to work out why m is used as a gradient. Apparently it was used in an old textbook or something like that. Basically, the point is there's no real good reason. And the c maybe because it's the crossing point. The American system uses y equals mx plus b, just to make things even more complicated, but essentially this is it. So you'll often see y equals mx plus c. Now, many students say to me, oh, I don't understand y equals mx plus c. Now, that's okay. That's because their teachers maybe hadn't been able to communicate to them probably that essentially what's going on here is that whatever's in front of the x is your gradient, and whatever's on its own that doesn't have the x will be your y-intercept. Now, before we look at some examples, I just want to explain how you can find your gradient or your steepness. Now, I've alluded to it up here, but essentially your gradient, okay, my gradient or steepness will be your change in y, okay, your change in your y divided by your change in your x here. Okay, so very often what you'll see this written as is gradient is equal to rise over run. So if you have a graph that looks like this, what you can actually do is draw a triangle like this, a right angle triangle, and this will be your change in y. So we often use this triangle here, which means change in. It's the Greek capital letter D, which means change in, and this is your change in x. Now, you don't necessarily need to know this this little triangle thing, but it just means your change in. And so it will be, your gradient will be your rise, is how much you, your change in y over your change in x, or rise over run. Okay, it's just how much it's gone up by divided by how much it's gone along. Now, just very quickly, just a note on gradient. If it goes up like this would be a positive gradient. Okay, I put the P and the VE of positive, and that would be minus negative. Okay, so any gradient that goes up like this, okay, would be a positive gradient. I'm going to put a little plus there. Anything that goes down like this is a negative gradient. And remember, we're reading from left to right. So if it's going up, that would be positive. Imagine you'd bought some shares in a company, or you're looking for the money in your bank account. If it's as it moves along time, it's going up, that would be positive. You certainly would be happy about that. If it was going down, however, that might be sad. Okay. Right, great. So I'll come back a little bit more of that in a bit. But remember, any graph has your this value here. Okay, this value right here. This is your gradient, and the value that's on its own is your y-intercept. Okay, so if we had this graph here, y equals 2x plus 5. Right, what's going on here is our gradient is 2. Okay, that's our steepness. Okay, and the number that's on its own, plus 5 here, positive 5, will be your y-intercept. So if we're being required to draw this, all you'd have to know is that it's going to cross at 5, and it will have a steepness of 2. So if this was the normal y equals x graph, our graph that we would be drawing would actually be double the steepness there, be y equals 2x plus 5. Okay, so it's just double the steepness there. Whereas if, for example, you had the graph y equals a half x plus 2, for example. Okay, that's my y, that's my x. Now, we'll be doing more of these in just a second, but here we go. If this is the normal y equals x graph, we could see that the steepness would be half of that. Okay, it would actually be much less steep, and it would be crossing at 2, so it might look like that. Okay, so it's much less steep. Your steepness, essentially, or your gradient, will be, as I say, how much it rises over how much it runs, how much it goes along. Now, very often what you might be done, they might give you is a graph here like this, and they tell you that this crosses at, say, 5, and this one crosses at 10, and this is not to scale. Okay, and they ask you to find the equation of the graph. That would be y equals something x plus something there. Now, what we do in order to find out what the gradient is, okay, what the gradient is, we're going to do we're going to find out the steepness using the rise over run. Okay, so gradient, which we often call m, will be our rise divided by our run. So we can see that this has risen by 10. Okay, so it's gone up by 10, and we can see that it has gone along by 5 there. Okay, so the rise of the run is 10 over 5, which 10 divided by 5 is 2. So that's our gradient there would be 2. So we can actually just pop that into there. And then it's fairly obvious. You can see that it's crossing the y-axis at 10. Okay, and that there is our y-intercept. Now, I'm just going to go over some graphs now and just show you, just so you get a feel for them. Of how they would sort of look. I've drawn these little axes here in anticipation of this. Now, the first graph that is most common would be the y equals x graph. Okay, so that's y equals x, and that's just a nice straight line that goes through 0. And we can see that there's plus nothing. There's nothing on the end of that. That's why it goes through the 0 point there. Okay, so we don't even need to put anything on the end. That's the y equals x graph. But say, for example, we wanted to shift it up. Okay, so what I'm going to do is I'm going to do a dotted line which will show where the y equals x would normally be. And if we do something that is the same steepness, okay, it's the same gradient, but it's say 5 upwards, the whole thing's been shifted up by 5. That graph there would be y equals x, because it's still 1x as the gradient, plus 5. Okay, so it's been shifted up by 5. Now, of course, these are not to scale, but it's just useful to kind of get a feel for what they look like. Now, the y equals x graph here, this is about a normal y equals x. I'm just using that for reference. Say, for example, we had a line that was twice as steep as that. Okay, now, okay, it's not perfectly drawn, but that could be y equals 2x, because it's double the steepness and it's still going through the origin, it's still going through the 0 point, so there's plus 0 on the end, we don't need to write it. So that would be one that's twice as steep. Okay, in the same way, if I had my y equals x line here, and I did a line like this that was half its steepness. Now, I've already sort of shown you that might be y equals a half x, because it's half as steep as the y equals x, and it's still going through the 0 point, so there's nothing on the end, there's no c. Okay, there's no value at the end. Now, what we could do is combine two of those together. So say, for example, as I said, here's my y equals x line here. And say, for example, we had one that went through, say, -3, okay, but it was double the steepness. Now, okay, it's not perfectly drawn there, but that could be y equals, now if it's double the steepness, it'll be 2x, but this one is crossing at -3. Okay, so again, the main thing I'm doing is showing you different examples of graphs. Now you can pause this video and say to yourself, right, okay, I can see how that's y equals x, because Mark's already shown that to me, and try and work out why this one is y equals x plus 5. It's got the same gradient, so that is a 1x gradient. Now you can write the 1 if you want, you wouldn't get it wrong, but essentially it'd be just y equals x plus 5. It's been shifted up by 5. Now, I'm going to show you negative gradients. So obviously this here is our positive. So this is y equals x, okay? But let me show you another line. This one here, as long as it's at right angles, would be y equals negative x, okay? That means for every value of x, say for example, when x is say 5, the y would be -5. Okay, it just takes the value in terms of minus. And what that actually does is flips the graph, so now it's sort of pointing downwards like that. Okay, so that would be a negative gradient. Now, if, for example, I had this graph here that was the same steepness, okay, it's the same steepness as the y equals x, but this is crossing at, say, 10, what would the equation of that graph be? Well, let's see. So the gradient, so it'd be y equals minus x, because it's the same gradient as the y equals minus x, but this one has been shifted up by 10. It crosses at 10. Okay. Now, we can then look at various examples of these. So say, for example, we have our y equals x graph here. Okay, and we've got a line, say, that goes, I'll do this one in say, green. Here we go. And this one here is much less steep. Say that it is half as steep. That would be y equals half x. Remember, this is now a positive gradient again, because it's not going down, it's going up. But this, say it crossed at 4, that would be half x plus 4. So have a look and just get a feel for what's going on with these graphs. Now, there are a few other graphs that you'd sort of be expected to know. For example, the y equals, here we go, let me just quickly, this is the y equals x squared. Now, obviously this, what I'm doing now is just doing sort of linear graphs, or straight line ones, but it would be expected that you did know a y equals x squared graph, and you should also know the y equals x cubed graph as well. Okay, so those are slightly anomalous, but I just wanted to make sure that I did at least mention them within this. Okay, now say for example, again, we were given a graph that went like this. Okay, went like this, and it crosses. Okay, so you were given this question, and this one crossed at say -5 and crossed here at -3. Now, this is a little bit more difficult. This is a negative gradient. Okay, so we're already into something quite difficult. So what we do now, and we've got a little triangle here. Okay, remember I said draw a triangle. Now, in order to get the gradient, so we're going to have y equals something x plus something. Okay, now I can see immediately that it crosses at -3. So I know that -3 goes into this box here. But what is the gradient? Now, I'll give you a clue. It's definitely going to be a negative gradient. Now, to find the gradient, we do our rise over our run. Okay, well, our rise here, okay, this has gone by 3. It's actually gone -3. It's actually gone down by -3. It has gone across by 5. Now, what I can actually do here, I can just do a little triangle just to kind of make things a little bit easier to see. I can draw this triangle where this is at -3 here. So that's 3, that triangle, and that's 5 there. We can see that our rise, or our drop in this case, is 3. It's actually -3 because it's gone down. What I often do is I just work out what the numerical value is, like the 3/5 or whatever, and then I decide whether it's positive or negative. But I'm just showing you right from the start, and it's gone over 5. So in fact, our gradient here is -3/5, and you can leave it as a fraction there. So in fact, this graph would be y equals -3/5 x -3. Now, of course, that's a much more complicated one, but it hopefully makes some sense. Now, say for example, I've got a graph that looked like this. Okay, so this is crossing at say -20, and this one here is crossing at say 10. Okay, now these are much nicer numbers. I started with a pretty horrible one for this one here, but let's have a look at this. So again, this is going to be y equals something x plus something. Okay, now what I'm going to do is just encourage you to use these boxes, and I use them simply because it really helps focus my mind of what it is that I'm actually trying to find here. So that's our y-intercept there. Okay, well, I can already see the y-intercept is -20, so that's fairly easy to fill that one in there. Okay, but the gradient, let's have a look at the gradient. So what I can actually do if I want to is redraw this triangle here. This triangle that I've got here, I'm going to just sort of measure that in yellow just so it's easier to see. I'll colour that one in. Okay, that's the triangle I'm looking at. Now, I know that this one crosses at 10 here, and this one crosses at -20. Okay, so I know that this has gone down by, this is 20, essentially. In fact, actually, because it's moving from left to right, it's actually going up by 20. Okay, and this one here has gone along by 10. Okay, so I have a triangle that is a 10 and a 20, but which one do I divide by which? Well, it is the rise over the run. So my rise here is 20 and my run is 10. So 20 over 10, and the answer there is 2, because 20 over 10 cancels to 2. So I can put that into my graph there. So if I want to write it out properly, that would be y equals 2x minus 20. That is that graph there. Okay, so now for you guys, have a think about the kind of graphs that you'd want to be able to sketch. You should be able to do them. I will do one more here. Okay, like this. So say for example, this crosses at say -8, and this one crosses at say 3. Okay, now again, straight away, y equals something x plus something. Okay, again, we want to do my gradient will be my rise over run. okay? And then here, oh, just make sure I dot my T. And then this one here will be my Y-intercept, or my crossing point. Now, immediately I can see that one, okay? That's at +3. So it's at 3. But let's try and work out the gradient. Okay, so what I've got, again, is a little triangle here. Okay, so this is my triangle within this. And so if I just sketch this triangle here, okay, that is terribly drawn. So let me just make sure, there we go. Right, so this is my triangle here. And I know that this goes up by 3 and it's across by 8. Okay, so it's gone from 8 to 0 here. Now, it's my gradient is my rise over my run. So in this case, my rise is 3, my run is 8. And because it's going, as we go along that way, it's going bigger. We're happy because it's rising, it's going bigger. So that would be a +3/8. So that's 3/8. So again, if I want to write that out properly, that's 3/8x plus 3 there. And by the way, the fractions in front of this x here can get pretty complicated. That's okay. I generally leave them as a top-heavy or improper fraction. Now, occasionally what you might do is you might get a graph that looks like this. So you might get y equals 3/5x plus 2/5 or something like that. Now, sometimes it is possible for the graphs to actually have fractions for both of those. And then they might actually give you, they might say, write your graph, to actually give the answer in the form ax plus by equals c. Okay, they might give it in that form where a and b and c are integers. Well, in this case, what we've got, if we've got this graph here, what we can do is we can multiply this entire graph by 5. And what that will do is it will get rid of these 5s that are on the bottom. So what we'll have here is 5y's are equal to 3x plus 2, because what it's done is it's got rid of the 5s at the bottom. And then what I can do is take my y's over there and my 2 over here. So what we end up with is -2 is equal to 3x minus 5y. And if we're trying to match this form here, I could write that as 3x's minus 5y's are equal to -2, meaning my a is equal to 3, my b is equal to -5, and my c is equal to negative, I'm not sure why I put it 20, my c is equal to -2 there. So that's if they ask you to give it in a slightly different form there. Now, talking of different forms, occasionally you might get questions where they say 3y is equal to 9x plus 12 or something like that, and they want you to actually plot this graph. Now remember, you need to put it in the form y equals mx plus c before you can plot it. So the best advice here is just divide everything by 3. So we have y is equal to 3x plus 4. Now we know that our gradient is 3, okay, that's our gradient. So we would do, for every, remember, rise over run, it'd be 3 for every 1 up, that would be our gradient. And plus 4, we know that it's going to cross the y-axis at +4 if we're drawing those. Now, the last thing to cover when we're talking about graphs is occasionally you will get questions where they don't even show you a graph. They might give you points like 2, 5, and say 5, give me a second, 11 or something like that. And they'll say, now these two coordinates, A and B, are both on a line. Find the equation of the graph. Now, this is a little bit tricky. What I advise doing actually is just doing a little sketch here. So we got our 2, 5 here, and we've got our 5, 11 here. And it shows that that is a positive graph. So this is our graph going off like this. Now, doing the little sketch helps me sort of visualize what's going on. But let me just show you this. So what we're going to do here, the first thing we need to do, remember, is it's going to be y equals something x plus something. Okay, and remember that this will be our gradient, okay? And this one here will be our y-intercept. Right, now how do we find our gradient? Now, in this case, finding the y-intercept is actually usually the easiest one because you can just look at the graph. But in this case, because we can't, my advice is start with the gradient. So what we've got here is we've got the coordinate 2, 5, okay? And we have another coordinate up here that is 5, 11. As I said, draw a little sketch of a triangle here, okay? And let's see what our rise is. Well, we know that the rise will be between the 5 and the 11, okay? Because that's our y values there. Because remember, all coordinates are x, y, and y would be your rise. So what is the distance between 5 and 11? Well, we know that's gone up by 6, okay? It's gone up by 6. We can see that because 5 plus 6 is 11. And then what we want to do is find out what our x change has been, okay, how much it's gone along. It's gone from 2 to 5 here, so that has gone by 3 because 2 plus 3 is 5. Okay, so now we have our little triangle where our rise is 6, okay, so our rise here is 6 and our run is 3, and that 6 divided by 3 is 2. So we know that our gradient is 2. Okay, our gradient is 2. Now, how do we find the y-intercept? Okay, so hopefully you're okay with this. I'll do one more example after this anyway. But how do we find our y-intercept? Well, we now have an equation. Okay, we actually do have an equation. We've got y equals 2x plus c. We don't know what our y-intercept is, but we do have c. Now, what we can do is we can take this equation, which has 3 unknowns, and actually use one of these 2 coordinates from above. Okay, so what I'm going to do is I'm going to substitute a, which is 2, 5, into this. Now I have an x value and a y value, which I can substitute in. So my y value is 5, and then we've got 2 lots of x, which is 2, and then we can plus c, which we don't know. Now, do you see that this has only one unknown? What I've done is I've taken my x there, and I've taken my y and substituted them in there, okay, for those reasons. So now what I've got is 5 is equal to 4 plus c. I can then take 4 away from both sides. 1 is equal to c. So we now know that c is 1, so I can substitute that back into my equation. Y equals 2x plus 1, okay? And that is how I found the c. I've just substituted a point into that, okay? Now, let me just give you one more example of this. So say, for example, we have these 2 coordinates, maybe minus 5, 10, and say, let's go for 2, and let's say, gosh, 24. Okay, now I've got my 2 coordinates here, and I'm asked to find out my the equation of my line. So that would be y equals something x plus something. Okay, now again, I love drawing this because it really focuses my mind on what it is that I'm trying to find. Well, the first thing I'm trying to do is find my rise over run. So what I'm going to do is find out what my rise is. So my rise is 24 minus 10. Essentially what I'm trying to do is find out what do you add to 10 to make 24? Well, that's plus 14. Okay, that's so 24 minus 10 gives me the what the rise is. So 10 plus 14 will give me that 24. Now what I'm going to do is find out what my run is, my x change. Well, minus 5 plus what makes 2? Well, that's plus 7. You can actually do 2 minus 5, which will give you 7. 2 plus 5. So what's happening here is I've got my rise over my run, okay, which gives me my gradient. We often call that m. My rise over my run will be 14 over 7, and in this case 14 divided by 7 is 2, so we have a gradient of 2. Now again, how do we find the y-intercept? Well, I have my little equation, y equals 2x plus c. We don't know what c is yet, okay? And I'm going to substitute one of those coordinates in here. Now, in the last question, I substituted the first one, but I'm going to substitute the second one here. I'm going to substitute the point 2, 24 into that, okay? Remember, this is my x here, okay? So I'm going to substitute that into my x, and my y is 24. So let me rewrite this equation. So instead of y, I'm going to write 24, okay, is equal to 2 lots of whatever x was, and x is 2 in this case, plus c. Now again, what's happening here is because these coordinates are both, these coordinates that I've just drawn here, both of those coordinates are on the line of whatever the one we're trying to create. They're going to be on this line, which means that the c value that we get will allow us to make that 24 and that 2 be on that same line. So essentially what we're trying to do here now is just work out what C is. So 24 is equal to 4 plus C. I'm going to subtract 4 from both sides here, meaning that that's 20 is equal to C. Okay, so we have our y equals 2x plus 20. Okay, and that is the answer. So that's how you can find the equation of a line from 2 coordinates there.